Chapter 8, Torque and Simple Machines. This is the schedule for this month. You'll be taking the Chapter 7 test on either Monday or Tuesday, the 2nd of March or the 3rd of March. 8.1 or Torque will be on Wednesday and Thursday. Simple Machines will be on Friday or the following Monday, and then we will have 3 different labs: a lever lab, a pulley lab, and an inclined plane lab. You'll also be presenting a Rube Goldberg machine that you created with some other students on the 18th or 19th. Review days will be on the 20th and 23rd. Chapter 8 test will be on the 24th or 25th. And then there's an early release date on the 27th for you to get ready for spring break. A quick lesson outline. We'll do notes as a quick review and on torque, and you'll have an in-class worksheet on torque that you'll be turning in at the end of the period. Your homework assignment up to before that is to read Chapter 8.1 and watch the 8.1 screencast and any YouTube videos that might be available. You'll need to take the practice quiz, and we'll take a practice quiz during the next period. Work from Chapter 5.1 is defined as a force applied over a distance. The SI units for work are Newton meters or joules from the function W is equal to Fd, where W is work, F is force, and D is distance. Energy is the ability of a physical system to do work. It exists in several forms such as heat, kinetic energy, mechanical energy, light or potential energy, electrical, or other forms. According to the law of conservation of energy, the total energy of a system remains constant, though it may be transformed to another form. Momentum is a derived quantity calculated by multiplying the mass times the velocity. This means that momentum has a direction, and it is always in the same direction as the velocity of an object's motion. The equation is P is equal to mv, and the units are kilograms meters per second. Angular velocity and acceleration, coming from Chapter 7.1, is the next topic. When an object is moved on a circular path, then its velocity is considered an angular velocity. Its perpendicular direction of the rotational plane, and it is related to the change in the angular speed and measured with units such as radians per second or revolutions per second. The angular acceleration shows the change in the angular velocity with time. Learning targets for today include recognizing the difference between a point mass and an extended object, being able to distinguish between torque and force, calculate the magnitude of torque on an object, and identify the lever associated with torque on an object. This is an illustration of a point mass and an extended mass. The point mass, as you can see, is in the center of this object. The extended object is the rest of the object. Point masses are used when the mass itself is not going to make any difference for the entire object. This would include when you have 2 very large objects attracting each other, or if you have something falling. Otherwise, you would use the extended object's mass. Rotational and translational motion. Motion in which an entire object moves is called translational. You can see this entire basketball is moving across here. Motion in which an object spins is called rotation. This basketball is spinning on its axes. Point or line above which the object turns is its axis of rotation, and it's really important to remember that an object can both rotate and translate. Torque is an action that causes an object to rotate. Torque is not the same thing as a force. For rotational motion, the torque is what is most directly related to the motion, not the force. It is created when the line of action of a force does not pass through the center of rotation. The line of action is an imaginary line that follows the direction of the force and passes through the point of application. To get maximum torque, the force should be applied in a direction that creates the greatest lever arm. The lever arm is the perpendicular distance between the line of action of the force and the center of rotation. So this would be the lever arm. Torque is created by force. And the formula for torque is tau is F times R times sine theta, which is the radius multiplied by the force. The units you use are Newton meters, but you do not use joules because torque is not considered a force. To calculate the torque and the force is applied perpendicular to the wrench, so the lever arm is 30 centimeters. Make sure you convert that to meters. In this question, you push on a door. It'll open easiest if you push A, opposite the hinge, B, the center of the door, or C, near the hinge. Think about where the door handles are typically placed, and that should give you an idea of where it would be the easiest to push if you were trying to open the door. Again, read Chapter 8.1 and watch the 8.1 screencast and the YouTube videos if they are available. Take practice quiz. You will take the quiz next class period.